Hello, good afternoon, thank you for coming. I am João Neto from VoiceInteraction, and I will be presenting basically an idea about our company and also talking a little bit about closed captioning and basically talking about automatic closed captioning. Just to give an idea about VoiceInteraction, basically we are a speech processing technology company. We are working systems for speech processing and to extracting knowledge from speech. And using this kind of technologies in different areas. And we are crossing the core technologies with different kinds of markets. And based on this, we extracting different kinds of products. And on top of this, basically the crossing between the technology, the market, and the products, we have also some language where we work, and this in some way are relevant because we are talking about systems which are language dependent. And according to the market that we want to work, we need to develop the systems for that kind of language. And what we are doing is working in different areas, in different kind of markets, and using this kind of technologies for that market and for that language. And what we, in terms of the company, we have been working in terms of media monitoring, in terms of extracting the knowledge from the media market, and trying to get some information from that kind of data. And we know that in the media there is a lot of data, and what we try to do is extracting that kind of knowledge. Another area is the captioning, where we are working for the closed captioning, both live and both offline. And that is basically the topic that I will be talking today. And another area is the transcription, where we have different kind of end applications where we can use these technologies. And another area is multi-channel and also multimedia. But basically I will be focused on the captioning and the systems that we got for this. In terms of the offer, we have different kind of products, and what we will be talking about is about our systems for audio image media and audio image server, which is the live and offline solutions that we got for this market. Talking now a little bit about closed captioning, okay? And we know that closed captioning by itself is some way a hard task, which is difficult because normally what we are doing when we are doing this manually, we have different speakers, different accents. Some of them are very fast speakers. That means it's very difficult to cope with that kind of speech rate. There are outside interviews. That means we are coming from planning speech to spontaneous speech, and that means makes the task difficult, okay? And because we are talking about very fast and diverse content, that means also for humans is a very hard and demanding task. And for the other side, there are huge amounts of video and needs for closed captioning. When we are talking about the station, they are producing 24/7, okay, in terms of amounts of data. Online content needs to be broadcast. And when we are talking about this, we are not talking only for accessibility. That means we are talking about for content for all, okay? That means if you want to make available a video on the web, and if you want to search that kind of content, it's very relevant to have access to the closed captioning, because we have some text and we have the ability to search on that kind of content. And the question that we are talking here in terms of closed captioning is the ability to transform all this kind of media in something which is useful for all, okay? And this is a very, very important task on that sense, okay? And because we are talking about production of a large amount of media content, that means we are talking about a task that needs to be automated, okay? There is no way that we can deal with this without having an automation system, okay? This is very difficult too. And also, when you are talking about scale, if you are not able to automate this kind of task, there is no way that you can scale for all the stations, for all this kind of content, okay? And I think, and this is the point, is it's time to do this kind of automatic closed captioning process, okay? And one of the reasons for this is we have been developing automatic speech recognitions for a long time, but if you look to what happens in the last few years are very relevant. We have faster CPUs, okay? That means we can deal with real-time tasks with low latency, okay? That means we have CPUs with good ability to do that, okay? Also, because we have large amounts of data that is available, which is also a good way to training the systems, okay? And we are talking about more data, more variability, speaker-independent models, large vocabularies. And what we want to do is trying to put all these kind of features, all of these kind of restrictions in an automatic speech recognition system, okay? And when we look to the task and we say, okay, we have a difficult task because we are dealing with so many different issues, but also it's an easy task to an automatic speech recognition system, okay? Because if you can deal with this large amount of data, and if you can extracting the knowledge from this data, is an easy task to an automatic system, okay? But still there are some problems, and I will talk about that. But what I want to say is exactly that, in the sense that now we have algorithms that if you have conditions in terms of CPU and memory, we can deal with this large amount of data and taking knowledge from that and training the systems according to the needs to have an automatic system, okay? And that is the point, okay? That means we are talking about a difficult task, but we are also talking about a good technology that we have available now and the ability to train the systems in order to extracting that kind of content, okay? When we are in some way on the process of changing from manual operation to an automatic operation, which is the point that we are discussing now in terms of industry, we have to assure certain points, and that are significantly relevant to this discussion, okay? When we are looking to an automatic system, that means we are talking about accuracies that should be on the top level, okay? That means we are talking about 95, 98, 100%, okay? And mainly when we are talking about the station and we are talking about changing from manual to automatic operation, that means you need to operate at that top level. That means you need to be there, okay? And to be there, you need to have a different kind of features in order to provide that kind of service with that kind of quality, okay? There is no margin for error. That means when we are talking about an automatic system, that means you need to have a very good level accuracy, or at least you understand where we can do very well and when there is some problems, okay? And that is also the point. And what we need to do is trying to creating the conditions around the system in order to perform as accurate as possible, okay? And that is the point, okay? We know that one of the big problems that we have on automatic systems is the out of vocabulary words. That means every day we have new words, new names, new places, some things that are happening. The automatic speech recognition system is a limited vocabulary. That means we can have large vocabularies, but always is limited. And that means we have to have some kind of capabilities to creating new vocabularies every day. to have the capacity to update the vocabulary with what is going on, okay, on that kind of information. And what we, as Voice Interaction, what we are proposing is using the automatic speech recognition technologies to cope with this kind of problems, okay? We are talking about our own technology and that we have been developing for a long time. And we have to understand that when we are talking about automatic speech recognition system, we are doing several tasks. That means there will be a pipeline of operations that have to run on real time with a very low latency. And to creating that, that means you need to have both from the technology point of view, but also from the engineering point of view, a good system in order to cope with all these kind of problems, okay? When we are talking about an automatic speech recognition, the first thing that we have to do is to deal with acoustic, okay? That means we're starting by have a no-speech detector, okay? That means we have to identify what is at the input if speech. If it's speech, we are working on top of that. And if it's not speech, that means we can deal in a different way, okay? We can have some kind of classification what is not speech, but basically what we want to do is to transcribe the speech part. And when we are talking about speech, we are talking about speaker, okay? That means you need to have information about the speaker. When there is a change of speaker, we are talking about speaker term. We have also information about speaker clustering. That means if you want to identify when a speaker appears, okay? And to have that kind of clustering, and also to have some speaker ID. If you want to put the name of the anchor or the name of the journalist, you need to have some speaker ID, okay? And again, when we are talking about all this pipeline of operations, all these kind of tasks, we are still talking about real time. We are still talking about low latency. That means you have to perform on a very high level in order to be able to use your technology, providing this kind of information, but still on real time with low latency, okay? And you are talking about acoustic speech processing, and now you are talking about models. In our case, we have different kind of models. We have acoustic model, which are basically trained with large amount of data using deep neural networks, okay? And these are relevant in the sense that we are getting large amount of data. That means you need to be able to deal with that amount of data. And for example, when we are talking about large markets, and the US market is one example of that, that means we have different kind of accents. We have different kind of pronunciations. We have different kind of origins of the speakers. Most of them are no native speakers. And you have to deal with that variability, okay? That means you need to collect data from different stations, and when we are talking about the station of New York, or a station in Florida, or a station in Los Angeles, or in Alaska, you are seeing different speakers, different pronunciations. And we want to provide a system that is able to cope with that variability. And what we are doing is just collecting data, okay? Because data is fundamental to get a good accuracy. We are just collecting data, transcribing that data, and using that data on the training systems, okay? And from us, what is relevant, each time that we have a new client, we collect data from them, we update the models with that data, we put all that kind of information on the models, and the models on the next day will be better than on the day before, okay? And that is the background besides this, is always improving, okay? And normally when we are talking about artificial intelligence, and when we are talking about machine learning, the goal is this, in the sense that we are getting more data every day, the systems are able to learning this, both in supervised or unsupervised ways, okay? But the systems are able to learning this data and to improve for the next day, okay? And besides the part of the acoustic model and the deep neural networks, we have also statistic models. That means we are getting information from news, just doing a lot of crawling from what is happening on the web, and trying to put all that information on the model, also to put that information on the vocabulary, and to grow the model, and to be always updated, okay? That is always the point. And on top of this, that means you have a good acoustic model, you have a language model, but now you need to, in terms of software engineering, you need to have also a good system that is able to do a search, and doing that search in an efficient way with transducers in this case, the composition of different transducers, and to do an online composition. And this is relevant because we are talking about live operation, and you need to be with low latency, with high accuracy, and to provide a good service. And because when the automatic speech recognition is producing the output, that cannot be enough. And what we are also doing is applying some natural language processing on top of that. That means we are doing some denormalization, trying to understand the contents, and if you are doing the date, instead of just producing the words, we want to producing a name, basically trying to do some summarization in terms of the output that we are producing. And also some doing automatic punctuation. That means we have a system that is working real time with a very short look ahead. That means we cannot wait to decide if at that point there is a punctuation or not. That means we have some acoustic cues, we have some language cues, and we have to decide if there is a punctuation there or not. And again, working always live and real time with low latency. And besides that, also getting some information for indexation, for tagging, okay? To be able to, in terms of natural language processing, be able to produce that kind of contents with tagging to give also information to what we can do after with that kind of contents. And we are talking about this kind of output, but we have also to do that in terms of product, okay? In our case, what we are doing is a system that runs on premises on the client. That means the software should be self-contained to be able to run 24/7 on the clients 365 days, okay? And for that you need also to have a good product in terms of software, okay? To be able to run that, to update the language model, to update the vocabulary, and to be always able to running 24/7, okay? And for that you need to have a good product, a very simple interface, good service, a good API, in terms of integration and the way that we can control the software, and also a good support, which is also relevant to a product. Okay? For that, in terms of, it's necessary to have a good team to be able to do that in terms of research and development. We need to always working on terms of the technology, and this is also very relevant in terms of the proposition that we are doing, okay? Basically, we have the Audims Media software, which is for real-time closed captioning, okay? And these are the language that we are providing. That means we have large vocabularies. We are working with something which is more than 200,000 different words, okay? And this is our approach for the live. We have another one which is Audims Server, which is for offline. That means if we have some pre-production, something which is pre-recorded, and you want to do the transcription, and you want to always just broadcasting later, that means you can do that offline, okay? There is the constraint of live operation. And we have also another solution for media monitoring, for compliance and for recording, that is able to monitoring a channel and doing that 24/7 and working on top of that. And these are the three approaches that we have here. And this is an idea of our clients. We are worldwide, and Basically, we have an office here in New York, in US. We have another office in Brazil that is working for South America and Latin America, and we have another office in Lisbon that is working for the Europe market. If you want to visit us, we are at SU 11021, just across here at the Connected Media, and we welcome you, and we have some demos, and you can show you what we are doing and our product. Okay? Thank you for your time and for your presence here. Okay? Bye-bye.